In this video I'll be explaining to you the first one is law of multiple proportions, second one is law of reciprocal proportions or law of equivalent proportions, and the third one is Gay-Lussac's law of gaseous volumes. Okay, so the first one, that is law of multiple proportion. Law of multiple proportions. Okay, now it states that suppose two elements, okay, when two elements are combined together, then two or more compounds are formed, such that if different masses of one element, okay, different masses of one element, suppose say for example copper and oxygen are the two elements. Now when they are combined together, okay, copper can, okay, it can form cuprous oxide or cupric oxide. Okay, now when two elements are combined together, they form two or more compounds. So say for example in this case copper and oxide. Okay, now when different masses of one of the element, okay, different masses of one of the element is combined with the fixed mass of the other element, then it bears a simple ratio to one another, which means the copper bears a simple ratio, that is, see, in this case the copper and oxygen are mixed in the ratio, okay, this ratio, and this one is in the ratio 63.5 is to 16. Okay, this one is 2 times of 63.5 is to 16. Okay, now in both cases the copper is in the ratio, okay, the masses of the copper are in the ratio 2 is to 1. Okay, we see this one, okay, are in the ratio 2 is to 1. So that is what it meant. Okay, whenever two elements are combined together, they form two or more compounds. Say for example in this copper and oxygen, when they combine together we get cuprous oxide and cupric oxide. Okay, so when they are when we see their masses, their ratios are in the simple ratio. Okay, now next one is law of reciprocal proportions or law of equivalent proportions. I hope you are clear with this one. Okay, now next one, law of equivalent proportion or reciprocal. Okay, reciprocal proportions. So here also we shall see with some example. Okay, now if there are three elements, say suppose A, B and C, okay, when these three elements, okay, are combined to give binary compounds, say AB, BC and CA, okay, when these three elements are combined to give binary compound, say AB, BC and CA, okay, then the ratio of the masses of B and C, okay, the ratio of the masses B and C, okay, the ratio of the masses B and C when they are combined together, okay, okay, when this B and C are combined together, then their masses of the ratio is in a simple multiple of the mass ratio, okay, is in a simple ratio when they are combined with A. Okay, that means A and B, okay, A and C, or C and A. Okay, this is what it meant, which means, see, the ratio that you're going to get here and the ratio that you will be getting here. Okay, so B is to C, okay, of these two will be of simple multiple with respect to the ratios of B and C. Okay, so let's see one example. I hope example will clarify your doubt. Okay, suppose we take three elements: copper, sulfur, and oxygen. Now we are to check the ratio of sulfur and oxygen. This is A, this is B, and this is C. Okay, copper mixed with sulfur will get copper sulfide. Okay, copper with oxygen, copper oxide or copper oxide. Okay, then SO2. So the ratio of this one is copper is 63.5 is to 32. This one is in the ratio 63.5 is to 16. Okay, so here we take the ratio of both S and O. The ratio of S and O is 2 is to 1. Okay, how we get this, like 32 is to 16, isn't it? 32 is to 16, so divided by 16. Okay, so we get 2 is to 1. Okay, now the next one is for SO2. Okay, SO2 is, this is 32 is to 32. So the ratio of S and O for SO2 or sulfur dioxide is 1 is to 1. Now therefore, you see, the ratio of this set and this set, okay, so it will be 2 by 1 is to 1 by 1. Okay, so which will give 2 is to 1. Okay, so this gives a simple multiple ratio. Okay, so hence law of reciprocal proportions or law of equivalent proportions is proved. Okay, now the next one is Gay-Lussac's law of gaseous volume. That is Gay-Lussac's law of gaseous volume. Okay, now under constant pressure, okay, and temperature. Under constant pressure and temperature, the volumes of the gas, okay, the volumes of gases, which are reactant, okay, the volumes of gases, those which are reactant, they bear a simple ratio. Okay, they bear simple ratio between themselves, which means suppose volume of gas A and volume of gas B, their ratios will be in simple, like 1 is to 2 or 1 is to 3. Okay, it will be in simple ratio. That is what it meant. Okay, then these two volumes, okay, are also in simple ratio with the product. Okay, so all the three, that is the reactants as well as the product, all of them will be in simple ratio. Okay, so for example, hydrogen, chlorine, it will give 2HCl. Here the volume is 1 mole, okay, or 1 volume. Okay, let us take it 1 volume. 1 volume. Here also 1 volume. Here it is 2 volume. So their ratios are 1 is to 1 is to 2. Okay, so that is what it says. Okay, Gay-Lussac's law of gaseous volume, which means when it is kept under constant pressure and temperature, okay, the gaseous volumes of the reactants. Okay, these are the reactants. They will be in the simple ratio or simple multiple ratio, and also it will be in simple ratio even with the product. Okay, so now in all these three laws, one thing is very common, that is it will have or it will show a simple ratio. Okay, it will show a simple ratio in all the three laws that I've explained to you in this video. So if I have to explain to you once again, that is the law of multiple proportions. In the law of multiple proportions, we have that two elements combine together to form two or more compounds, such that different masses of one of the element which is combined with a fixed mass of the other element, then they bear a simple ratio, okay, to one another. Then law of reciprocal proportions or law of equivalent proportion was that, like, if three elements are there, okay, and they are combined to give binary compounds, say AB, BC and CA, then the ratio of the masses of B and C when they are combined together, okay, they give a simple multiple of the mass ratio when they are combined, okay, separately with the element A. Okay, then Gay-Lussac's law, it says that, like, under constant temperature and pressure, the volume of the gaseous reactants, okay, the gaseous reactants, they bear simple ratio between the reactants, okay, and also with the product. So that was all about the three laws. So it was most, I think in all the three laws, it was about only a matter of that simple ratio or simple multiple ratio. Okay, so I hope you are clear with it.